Hi, everybody. It's Josh Barley here inside NASA's Mission Control Center here at the Johnson Space Center. I'm joined by my friend Melanie Miller, who I think has probably one of the coolest jobs here inside the room. She's a robotics officer, so she's in charge, and her team is in charge of actually operating the robot arm, the Dexter, as we call it, the special purpose dexterous manipulator, and all sorts of things. But you were a key part of Dragon coming up to the station. So talk a little bit about what the crew did, what your team did down here, and kind of how you guys pulled it off.
Well, we started the day. Um, we started the day earlier than the crew got up, and we set everything up so that we had two workstations operating in case one went down. The crew could do a quick switch to the other one. And then the crew monitored the vehicle as it got closer and closer. We were in the background working with the flight control team to decide if we were ready to go for the next step to get a little bit closer. Finally, we got to 30 meters, and there was a lot of discussion about what the lighting was going to look like if we went to what we call into the capture volume, which is 5 meters from the arm and 10 meters from station.
Okay.
And we decided to go ahead and go, and so the crew did their capture at night, and the lighting turned out to be okay. And on the ground, we were setting up for them all the cameras and things that they needed and watching over their shoulder to make sure that the Dragon was in the proper volume and everything looked good. We gave them a go. They went in and captured it pretty quickly. And once they captured it, they did a small maneuver to get to an expected position. We called it the capture position.
Okay.
And after they were done, they handed it over to my team, and we maneuvered Dragon through two auto sequences to about 150 centimeters, meter and a half from the install point. So it was a big maneuver. There was a lot of things going on the ground and on board during that time. My team was focused on moving Dragon, and at certain points in that maneuver, we would call to the rest of the team, this is the position we're at,
Right.
so that they could kick off other things like the space station maneuvering to the install position, the whole vehicle. And we also made a call once we finished so that the SpaceX guys could roll the arrays around to the proper position for install. And we were calling up to the crew saying, hey, take a look out your window and look at the berthing side of Dragon and inspect it to make sure there's no damage so that we can seal up good. So all that was going on. It was very busy, and on both the on board and on the ground. And that was a change from last mission, because last mission we had the crew do everything, so it was all serial.
They did everything, right?
Yeah, they did everything last time. This time we did a lot in parallel, so it was exciting, and it went very smoothly.
So how do you, it's kind of nuts to think that you guys are down here, basically controlling this arm with this big spacecraft on the end of it, and you can't see it. I mean, sometimes you can see it on the video monitors, but you're really just kind of trusting your training, trusting the system's going to work as they are expected to. So, I mean, what is that like as a controller to be sitting here in mission control and kind of basically flying the spacecraft that you're not anywhere near?
We practice a lot doing it offline, and we design the procedures that the crew use to fly as well, and we've done that for many years. And so now we are executing those procedures from the ground that we have had crews for several years do. So we have a lot of a lot of history and background, and sometimes you're just doing your job, and it seems like it's just a normal part of your day, but then you realize I'm moving this huge spacecraft in space, and
it's flying really fast.
And it's and you need to be really, really careful and just be at the top of your game, watching all your data. So even when we don't have video, we do have data while we're flying, so we can see the arm joint angles, and those feed into a simulator we have that's really neat, that simulates everything on space station. It simulates the solar arrays moving from the data. It even simulates Dragon flying in and all the arm motion, and that's all fed from real telemetry. That same simulator is what we use to plan the trajectories, because we can actually fly it in a simulator mode, or we can have it run in a real-time mode, we call it, based on the data on board. And so we use that. Sometimes we'll even put it up on the big board when we don't have video in the control center, so that everybody in the whole team has a good situational awareness of what's going on. So, and we train, we have 3 people, and there's a certain protocol to everything we do, almost like we're in the military. We take it very seriously. We each check each other. We check what the arm is doing, and we train certain calls that we would make if something didn't look right. My backroom, for example, if they see something wrong, they would say stop motion and or safe, and I have a command up on my display, and I can click that. What it does is it stops everything.
Instantly.
Just instantly. Safes the arm, and everything stops.
It's whenever it comes time for Dragon to say goodbye, it's basically going to be the process in reverse, right? So the crew is going to take care of basically uninstalling it. And are you guys going to steer it around? Is it going to be the same thing as last time, or is it different?
It's different.
Okay.
Last time the crew did everything.
Okay.
This time the crew will participate in unbolting.
Okay.
The common berthing mechanism that has Dragon attached at the node, and then we'll actually do the unberth. We're going to fly from that zero plane to 1.5 meters,
okay.
And then we have a big auto sequence that puts us into the release position. So we'll do all the arm maneuvering with Dragon on the end of the arm. Then the crew will pick up with the actual ungrapple of Dragon, we call release, and the back away maneuver.
Okay.
Because that is a time-critical safety type thing, and we wouldn't want to start doing that and then lose video from the ground for some reason. So that's our plan.
So is it fun doing this kind of job? I mean, does it ever become normal, what you're doing? I can't imagine that it does.
No, it is fun. Actually, I think we have the best job.
Yeah.
And we get to train the crew before they go up.
Yeah.
We get to train the crew when they're on board for doing critical operations like EVAs or Dragon captures or releases. And then we get to participate in the operations while it's going on.
Yeah.
So I think that covers the gamut. It is an awesome privilege to be able to be certified to do this kind of job and be selected.
Yeah. Last question for you, and I know because you got to get up there and actually talk to the crew about these procedures here in a little bit, but the end of the arm, I think that whenever I had to learn about it, the thing that surprises me is that I always thought it basically kind of bolted into something. It's not. There's snares on the end, right? So they kind of pull tight. And matter of fact, you guys are going to be pointing it at the cupola, I think, later on today for Sunday to take pictures of it and to examine it. So talk about the mechanics of it. It's really a very kind of smartly designed arm by our Canadian friends. Talk a bit about kind of the design of it.
Okay, so we call it, the Lee is like a can.
It's a latching end effector, right?
Yeah, it's a latching end effector, and it looks a lot like a can, except that it has 3 wires, or we call them snares, and the wires get twisted around until they wrap around a peg called the grapple fixture that's on Dragon, and that peg has a head to it like a nail.
Yeah.
So the snares actually wrap around the pin,
kind of choke it,
and then they pull it in. We call that the carriage. The carriage retracts,
right,
and it pulls in until the snares are tight on that head of the nail of the grapple fixture, and pull it in tight till the face of the can is flush up against the grapple fixture plate. And there's a lot of tension there, and the tension is what holds it onto the arm.
It's an incredible design. I think that's one of the benefits of having something up in space. Not sure if that would work here on Earth or whatever, but it's funny to see how big the thing actually is at the training facilities we have here in Building 9, the Space Vehicle Maka facility. I mean, it's just 58 feet long. It's just huge whenever you take a look at it, and the end of it is just enormous. So it's always fun to watch what you guys do. I wish I could go over there and do it myself, but I don't think I have the training to do it. So we should swap jobs sometime, So. All right, that's Melanie Miller. I want to thank her. Thank you very much for stopping by. It's always fun to talk about this kind of stuff, and we'll be watching at the end of the month whenever you guys get ready to release Dragon back for its reentry back to the Pacific Ocean.
Yeah, that will be great.
All right, we'll see you later.
All right.